Two big news stories about the interstellar object 3I Atlas. First, NASA has broken its silence. They will release images of 3I Atlas via live stream on Wednesday, so they have opened the live stream page. The broadcast will begin at 12 p.m. Pacific Time on November 19. That's where we have the important planetary geometry, which is interesting because it has a lot of implications for communications failures and also for moments when the model fails in terms of communications. That's pretty interesting. They're going to turn off the chat feature. So if you want to see what NASA is going to release, not just from their high-rise images, but from any other information they've collected during this outage, it's only a few hours away. Stay tuned, because what happens next will blow your mind. If you are fascinated by the mystery of Atlas 3I and want to see more amazing cosmic stories, hit that like button and let the universe know you are watching. Every click helps keep the search for the unknown going. Comment below and let me know where you are watching. I want to see what places in the world are witnessing this with me. A remarkable development has just been recorded in space. A new coronal mass ejection, CME, has escaped the Sun and is heading straight for 3I Atlas. The event is from the sunspot cluster that caused the recent geomagnetic storm. While not the most powerful explosion in the recent series, the CME's trajectory matches 3I Atlas's position almost exactly. According to space weather simulations, the collision could occur on the 22nd at 12 UTC, a time that has U.S. space monitoring agencies particularly alert. Analysis of ecliptic data shows the relative positions of the Sun, Earth, Venus, and 3I Atlas, and orbital charts constructed from motion parameters confirm that the CME is crossing the exact region where 3I Atlas is currently traveling. While predictive models are never perfect, this trajectory is considered very clear. Coronagraph images capture the entire process of ejection from the corona, showing that the CME was not aimed at Earth, but was ejected from the far edge of the Sun, right in the region where 3I Atlas is present above the ecliptic. Observations at a wavelength of 131 angstroms show that the explosion occurred from the 17th to the early morning of the 18th universal time. Right from the first frames, the flare and the jet of material were clearly visible, strong enough to determine the direction of the CME was pointing straight at 3I Atlas, although most of the event was on the far side of the sundial. This raised further concerns when 3I Atlas suddenly became unusually alive in recent weeks. Sharp tails, flashing jets of material, and a wide, diffuse halo. These signs were closely monitored by U.S. telescopes, from ground observatories to NASA systems. Previously, when repeatedly hit by CMEs, these features almost disappeared, leading many experts to suspect that the observation angle was unfavorable, or that there was a strange electromagnetic phenomenon temporarily obscuring the object's tail. As 3I Atlas moved into better view, it suddenly became active again after its close approach to the Sun, although it was still quite fragile from the surface of the star. This phenomenon reminded many American researchers of unpredictable comets in the solar system, because powerful CMEs can deform the plasma in unusual ways. However, what puzzled observers was that 3I Atlas's reaction did not follow any familiar pattern. It was from here that fringe theories began to flare up on American scientific forums. Was 3I Atlas really just an interstellar comet, or did it have previously unrecorded physical properties? Why did it react more strongly after each CME scan as opposed to the usual weakening? Some independent analysis groups even question whether 3I Atlas's plasma structure belonged to a type of matter that even the U.S. Space Warning System had to pay special attention to. Observations from previous missions, such as Rosetta, have seen comets being swept by CMEs, with the magnetic field around them spiking from 30-50 nanotesla to 300 nanotesla. Cometary magnetic fields form when escaping gas is ionized, creating a complex system of plasma layers, including ionopauses, regions of internal magnetic fields, and shock waves where solar wind is trapped by thick dust. This is a highly volatile environment, so the latest CME and possibly more to come are expected to continue to wreak havoc around 3I Atlas, while amateur astronomers around the world are capturing the sharpest images ever. The object has a rotation period of about 16 hours, with a slight 0.1 hour oscillation, with a slight wobble. What is controversial is the structure of the jets. Many are directed downwards, others are not diffused in the ideal way. The theory is that the gas escaping from a rotating object should spread evenly, but that is only true if you ignore the complex electromagnetic environment of space. With a small nucleus, the interactions between plasma, charged dust, and solar wind become much more complicated than the traditional model. It is at this intersection of plasma physics, weak magnetic fields, and wobble that the big question arises: is 3I Atlas really behaving like a normal comet, or is it revealing properties that modern science cannot explain? Under normal conditions, gas in a vacuum would spread out into a uniform cloud. That assumption is correct, but only if you ignore the fact that space is an electromagnetically complex place, and the 3I Atlas nucleus is so small. This creates anomalies, and perhaps is where the real mystery begins. Hubble's original estimate put 3I Atlas's core at around 2.8 kilometers, 1.7 miles wide. However, new analyses by several independent research groups in the United States have come up with significantly different numbers, with some models estimating the core's diameter to be as much as 50 kilometers, 31 miles. This unusually large discrepancy leaves scientists with an increasingly troubling question. How big is this interstellar object? It's this gap in data that makes NASA's new HiRISE image set particularly exciting for the U.S. astronomy community, as it could force all previous calculations to be rethought. The extremely high resolution of the HiRISE camera on the Mars Reconnaissance Orbiter, operated and monitored by NASA and science teams from the University of Arizona, allows for much finer details of the Martian core than can be seen from Earth orbit. The data collected on October 3 is considered key to more accurately estimating the object's true size, which in turn will help determine the extent of outgassing, mass loss rate, and anti-gravity acceleration that Atlas 3I is experiencing. Without precise measurements, all measurements of its mass, density, or albedo are based on assumptions, making simulations of its behavior largely guesswork. In data analysis groups in the United States, some researchers have begun to question, could the extreme fluctuations in size estimates be a sign of a heterogeneous structure or a type of object that science has yet to classify? Some more conspiracy theorists have even suggested that 3I Atlas might not be a single solid nucleus, but a multi-mass structure, perhaps even a hollow object, similar to some of the strange meteorites that have puzzled U.S. scientists for years. While there is no concrete evidence to support these bold claims, the fact that NASA and HiRISE have had to reassess a parameter as basic as size is enough to make the observational community curious. Is 3I Atlas challenging traditional physics models, or is it telling a whole new story about what might exist between the stars? While waiting for the HiRISE data analysis to be completed, the question of 3I Atlas's true size continues to fascinate U.S. research agencies, and many believe the upcoming answer will be much more surprising than what science predicts. Current observations show that 3I Atlas has a rotation period of about 16 hours and exists in a large surrounding plasma environment. Remarkably, its nucleus is a very small object, while the surrounding plasma cloud is estimated to be about half the diameter of the Sun, or nearly 700,000 kilometers. Normally, the size of this plasma envelope increases significantly as the object approaches the sun, forming a giant space filled with ionized particles, with the slowly rotating nucleus at the center. Although the data are far from conclusive, analysts agree that plasma processes cannot be ignored. It is often forgotten that as soon as gas and dust escape into interplanetary space, they are immediately ionized and become part of a highly dynamic electromagnetic environment. From there, electric fields, magnetic fields, and electric field gradients can guide and control the flow of ions and charged dust particles. It is these interactions that can create stable, outflowing plasma channels, despite the small, slow spinning nuclei. Sophisticated plasma models show that maintaining stable plasma flows is entirely possible in such an environment without any unusual assumptions. However, conspiracy theories continue to circulate in the American astronomy community, especially on independent analysis forums. Some have suggested that if 3I Atlas has an inexplicably stable plasma structure, it may harbor some kind of strange technology or an unknown energy source. A few weeks ago, there was even speculation that the object could be a black swan event caused by an extraterrestrial civilization. However, in reality, there is no evidence to support this assertion. 3I Atlas is still following its original orbit, without any deviations or unusual signs of orbital control. With that being said, the plasma physics explanation remains the most plausible option for a science-based approach without resorting to the alien technology hypothesis, although that prospect has always been a source of curiosity among the American public. The author of the analysis also emphasizes that this is only his own opinion based on data and research, and recommends that followers do their own research before drawing any conclusions about the true nature of 3I Atlas. According to the latest orbital data, 3I Atlas is still on track. Real-time observing maps, like the Sky Live, show that the object entered a favorable viewing position on the 17th, and the view from Earth will continue to improve as our planet moves toward its optimal orientation. Over the next few days, the orbital time-lapse shows that 3I Atlas will approach perihelion on December 19th, giving it a better chance of seeing its tail than at the previous conjunction when it was mostly obscured by sunlight. As observing conditions expand, U.S. science and defense agencies are preparing to enter a period of intense monitoring. This monitoring is not just purely scientific. Even small fluctuations in interstellar objects must be evaluated as a risk factor, especially after the debate about 3I Atlas's possible unusual behavior in a strong plasma environment, or after recent CMEs. For U.S. defense analysts, tracking an interstellar object is also a way to test the sensitivity and effectiveness of space early warning systems in the context of global strategic competition. At the same time, political economic theories began to emerge. Some commentators suggested that if 3I Atlas showed any signs of abnormality, it could impact sensitive markets, such as the commercial satellite industry, space risk insurance, or defense contracts related to orbital monitoring. There was even speculation that some governments, including the United States, might use the attention focused on the object to obscure internal issues, though there was no clear evidence for this hypothesis. From a military perspective, some experts believe that tracking 3I Atlas is an ideal opportunity to test strategic technologies such as low-frequency radar, space sensors, and high-speed object tracking systems, simulating defense scenarios against unknown threats from beyond orbit. Still, scientists stress that 3I Atlas's orbit remains in line with its predicted trajectory and poses no immediate danger. The fact that its tail may become more visible in the coming days is largely due to a favorable inclination and improved parallax conditions, not a sign of a mysterious change. But Like all objects from outside the solar system, each approach to the sun brings with it unanswered questions, making 3I Atlas both the subject of serious study and the inspiration for countless fringe speculations. While 3I Atlas continues to be a focal point for the astronomical community, a technical issue has quietly clouded public perception. Most live-streamed observations of the object fail to adhere to basic principles of faint object photography. 3I Atlas is not a bright planet like Jupiter or Venus. In fact, it is much dimmer than Sirius. To capture the object's true structure, particularly its tail and slender jets, observers must use image stacking to increase the signal-to-noise ratio. Long exposures only capture more light, but without stacking, details are distorted by background and atmospheric noise. This explains why consumer telescopes like C-STAR only produce a limited image, a faint coma, a hint of a tail, but no clear image at all. By contrast, images from professional equipment with hundreds of exposures, 182, for example, show the tail, the sunward jet, and the delicate structures around it. Veteran astronomers in the U.S. emphasize that proper imaging is essential to accurately depicting 3I Atlas's shape, and that's nearly impossible to do in real-time live streaming. Misunderstandings based on incorrect observations have led some observers to conclude that 3I Atlas has no tail, and then to doubt and even attack those who prove otherwise. In fact, the problem lies entirely in the imaging technique, not the data. Those who use accurate methods have clearly noted its tail and jets. Meanwhile, NASA has begun releasing official images from multiple telescopes and spacecraft. In its latest paper, Hubble even directly calls 3I Atlas an interstellar comet, showing its growing resemblance to comets in the solar system, though it still doesn't look exactly like Oumuamua or 2I Borisov. For U.S. researchers, 3I Atlas is still considered a unique interstellar object. It could be a planetary fragment, a remnant of a distant star system, or a type of extinct exoplanet, none of which have been ruled out. In the context of increasingly fierce competition in space technology, many analysts believe that NASA's proactive public disclosure of detailed data also has a strategic element to affirm the leading role of the United States in space surveillance and prevent the spread of conspiracy theories from abroad. Attention is also heightened when a large CME is expected to collide with 3I Atlas around November 22. If that happens, the observation community hopes to record the phenomenon of tail separation, a rare plasma effect when the CME hits the ionized layer of the comet. This could become a rare observation moment in many years. Space models, however, still offer a word of caution. The CME is likely to hit 3I Atlas, but small deviations in the solar wind or plasma structure could cause it to pass by without significant change. In the United States, astronomers, space meteorologists, and even some defense analysts are keeping a close eye on it. Some speculate that the impact of a CME, if it is dramatic, could be overinterpreted by the public, especially after the recent black swan craze. Some commentators even see the event as an unexpected test of the unprecedented situational awareness capabilities of the United States Space Warning System. Several observational teams have begun to develop scenarios. A CME powerful enough to deflect plasma, create new jets, or reveal nuclear structures, all of which remain a mystery. But what has captured the American public's attention are more radical theories. The possibility of an anomalous core that traditional comet models cannot explain, or the prospect, though without evidence, that 3I Atlas could hide technological structures that have been shrouded in plasma over time. Some have not hesitated to compare it to Oumuamua, which has been controversially described as a dormant probe. Of all the theories, one thing is certain: all eyes are on 3I Atlas, And any small changes after the upcoming CME could bring the stories that both science and the American public have been waiting for a long time. In conspiracy-minded analyses, it has even been suggested that 3I, Atlas's response to the CME, could help determine whether it is an empty shell or some kind of ancient device from a long-lost civilization. These are all unproven claims, but their existence demonstrates an unprecedented level of interest and curiosity in this interstellar object, one that NASA has been closely monitoring and never completely ruled out before definitive data was available. In the coming days, all eyes will be on 3I Atlas as we wait to see how the coronal mass flow will impact and what changes it might cause. Whatever the outcome, this will be one of the most exciting interstellar events of the year. If you want to stay up to date, see detailed analysis, and follow the latest images as soon as NASA releases them, be sure to subscribe and turn on notifications. This will ensure you don't miss any important developments in 3I Atlas's mysterious journey.